um, stable diffusion, so many things. I'll tell you that each and everything later in the session. And the prompt engineering, what you need to ask to them, if the AI generating images for you, you need to ask them, right? It's supposed to be a right way. Otherwise, it will not be perfect. Each and everything we will go one by one. If anywhere you have any question, you can ask me. Now, when it comes AI, the big question is where it is used. There is no such thing has to be come from us. It is used in education, entertainment, media. I'll show you a demo. I'll show you a video. Now, this is a small video about how the AI can be used, or AI vision can be used in the supermarket. This is the live product now. Okay, you can see like the people are picking up, and then because of that there is a empty rack. There is a empty shell which can be. Now it can automatically order the product to the vendor, and then vendor come and fill it, the out of stock orders. See, it automatically triggered. So now they can come and fill it out. This is already implemented and ready. Okay, you need to understand that. Likewise, AI can be used in many places. Okay, now let me go to the other slide. Now you need to understand that what is AI, what is machine learning, what is deep learning. Okay, the artificial intelligence is a big umbrella. It's a framework. In order to enable artificial intelligence, you need machine learning. It is basically an algorithms. Okay. See, for example, artificial intelligence is talking about concepts, saying that like I need to identify the different objects in the image, or I need to naturally process the language. It is a concept. Inside that, like to solve each and every your natural problems, you have different machine learning algorithms. Take an example of linear regression. You have that SVC, like SVM models. You have KNN model. All those models are a different machine learning algorithms which is used to leverage your problem or solve your problems. Okay, the deep learning or neural network is in the other sense, where it contains a collection of nodes into the different layers, which is solving the problem using these machine learning techniques. Okay, so this is the three different layer. You need to understand that, usually it will be like can be utilized like vice versa. Like you can say that, okay, we can solve using AI, or you can tell that you can solve using machine learning. There is not much difference, but still in the context, you need to understand that AI, it's a concept, machine learning algorithms, which is like tools, which is giving a life to the AI concepts. Okay. And I want to tell you that many times we are just confusing between the traditional programming and then AI model. Okay, in the traditional programming, what we are doing, we have the data, we have the program, we put both into the input to the computer. Okay, that provides an output. For example, let us to take a case of like salary prediction. Okay, 1 minute. So let me to take this one. Let me to go to the Colab for this case. Okay. So usually when it comes salary prediction, you are able to hear me, right? Take an example of see, very simple. Take an example of I have an years of experience into this column, and then I have a salary into this column. Now when I pick this, and then when I go for an insert and then chart, for example, this chart, and then when I say that add trend line, and then in the trend line, when I say like parameter trend line, so it gives me that the value of this one, right? This is ax plus b. It's a quite normal linear formula. Okay, so in order to make this as a program, so what you do, this is the number, you got it there. So I'll have this, I'll go to my MATLAB, sorry, my Colab. I have a new book. See, this is Colab using the Jupyter notebook. If it is an open source version, in Google it is called Colab, where you can write your programs, Python, any research works, and then you can get the result directly. The good thing about here is you can get the GPU. You can see the runtime. See the TPU, T4 GPU, it's a graphical process unit. Basically, it has a more power than the normal CPU. You can leverage it. Okay. So for this, it's quite simple. From this sheet, I am trying to predict some value, like, it provided like, up to 10, I want to predict if I have working 24 years, what will be the salary. Okay. So now it provides me the value. So now it is actually connecting here. It means there is no environment so far attached with this. An environment in sense, it is a CPU, memory, everything has to be attached, right? So first it is allocating, see here, it is attached now. Okay. Not defined, yeah, just an year here. So I just analyzed my sheet here. I just prepared offline, like, a sheet, and then I understand this linear regression, and then I am doing a coding here. So what it does, it gives me this value, and then I can able to predict my salary accordingly. This is a traditional way of programming. In case of machine learning, we do bit differently. For example, when it comes machine learning, what we do, you take the data, you take the output. For example, in this case, the data output, like, the data will be like the number of years, and then the output will be the salary. Feed it into the system. Then it generates the model, linear model or exponential model, or maybe any LLM model, anything which you can call. This is basically which is called machine learning models. It creates the model. Then you put your data as an input, like, I want to predict for the year 24. Then it predict output. In this case, you don't write any logic for your particular problem. You generalize your problem, you gave it. For example, for the same salary prediction, I will again go to the Colab. Let me see where that's available. Okay. So I don't want to save it first. So I'm just disabling. I am taking my program. And I need the salary data. So the name of the sheet is this. Let's put it here. So it will be ROI, and then you need to have columns, years of experience and salary. And then I am, see what I'm doing here, I am splitting into test set and training set, and then I am using linear regression. Then I am fitting, then I am trying to predict, here the prediction will happen. So let's try it out. So now you can see that I was able to predict the value. Here you see I manually look into the data. I manually see how it plotted. Then I see, okay, it is plotting like a linear. Then I am preparing a linear regression curve. Then I am picking the coefficient out of it. But in this case, I didn't say anything. Okay. The same way I can try with all other regressions here, multiple regressions here. and then I can try to find the mean square error to say that which one has a minimum mean square error will be more accurate in the prediction. So this is the difference between a normal and the machine learning. In the machine learning, you are actually not doing any, or you are not trying to solve the actual problem by yourself. You are delegating that problem to machine to think of its own and identify these parameters. See, in this case, it's a one, like, just you are having two variables, right? In the machine learning, usually you have multiple variables, and which is sometimes with the large language model and all, it is millions of parameters will be there. Okay, that is how efficient it is. Like, if it is a simple, you can able to imagine, okay, it's a one dimensional or two dimensional, but 3, 4, hundreds of dimensions when it comes, we cannot even imagine it. That's the advantage you have with the machine learning models. And if you want to go for a small graph, you can still use it. For example, here also I'll display that what is the coefficient which we got it out of it. For example, this model, we got the coefficient there, right? Like this 940, it's almost near to that. And then this B, which you are having here, that is the coefficient of A and intercept. And if you want to, let me go the chart directly. So here we are using Matplotlib. So here you can see it's a similar diagram. So in the machine learning, what you are doing, whatever that you are doing in the real world, when you are putting your brain to analyze the data and then give an input, in the machine learning, it does automatically for you. Okay. So here, as I told you, instead of linear regression, you can have any number of regression and then run it and predict it, then find the square error. Which one has a minimum error will be a perfect one. Then you pick it out. And just imagine, already you know overfitting, which one has 100% perfect, we will not agree because it is called overfitting. Okay, we need to have like average of 90 to 95 will be a perfect machine learning models. So this is the very simple difference between the traditional programming and the machine learning models. The other important thing which you need to understand, that how you are interpreting the values. For example, machine learning model all can understand zeros and ones or numbers in the other sense, not any ABCD or word, nothing. So all has to be converted into a number. So any value you are giving as an input, basically a domain. Just imagine if it is a ABCD can be replaced with 1, 2, 3, or if you are doing a word, for example, you want to classify with the different words, you need to give each and every word as a number, something like that has to be done. Okay, that is called, encode and decode, or you can say labeling. Anything has to be done before proceeding anything. So when it comes to machine learning models, you need to understand that this is all about numbers. It's not about text or not about image, anything. So as I mentioned, image, when you go to the next one, the classification example, just imagine you have a list of all image here. How these all will be converted into numbers? Very simple. Just imagine each and every of these pictures has 12 pixels. Just imagine this 12 pixels. So 12 cross 12, it is 144 pixels. Each and every pixel will have RGB values. Each and every RGB will have 0 to 255 values. So now 144 into, like, you have another 3 numbers will be multiplied into a big array. Okay, that array will be trained with the machine learning model. Okay, so in order to classify such examples, so in this case you want to classify this, either it is orange, apple, banana, or leaf. Okay, the 4 output you need to understand what is 4 of them, and you have input of like 12 cross 12. Take an example of, you have a single array of pixel, monochrome image, then you have 144 pixel. These will be sent to a kind of layers. Okay, this is where your neural networks comes in place, or deep learning comes in place, where you have your input layer. In our example, 144 pixels, and then you have your hidden layers, and your output will be 4, right? Whether it is apple, orange, banana, or leaf, all 4. So this is how it will be mapped. All your inputs will be mapped with your output. It will be automatically trained with weighted average, and there is so many algorithms will be run internally, and then gives you output. So this is where everything mapped very cleanly. Anything you want to solve, first you need to convert that into a proper array of values, then put it at the input. Then there is a lot of debate, like, how many input layer, how many hidden layer, how many output layer. This you have to train with multiple inputs layers, multiple hidden layer, 2, 3, 4, 5, 10, and then output, it's R&D basically. Then you need to finalize that. Okay, I have tried with this many number of input with 5 layer hidden and 3 layer, 2 layer, 1 layer, and then 7 layer, 8 layer. Then which one is very optimal in terms of time, in terms of memory, in terms of resource, in terms of accuracy of the result. This is how everything will work. Now we are just bit into that. So now we know that what is our existing program AI model. Now we are jumping into that, how image analysis will start working. So in order to do the AI vision, there are multiple parties involved. Very simple. We need to have a sensors. Basically, in this case, we have a camera where it analyze or send video. This video will be chunked into images. Take an example of sampling. Most of the time, like one sample per second is more than enough. Like, one image. Usually the video will have 24 very earlier, 29, usually now all has 29. When you have a slow-mo video and all, it will be 60 frames, some of them 120 also possible. Okay, but in order to do machine learning or vision, you need to have one sample per second, which is more sufficient for most of the work. Okay, take an example of the product in the shelf. If the product is not there, it doesn't require that in a second you need to process 30 times, right? 1 second, like even 5 minutes, one also, it's fine. You check now a shelf and then identify what all the areas are empty. Then after 5 minutes, you can check it again, because within 1 minute, how many people are going and pick it out. So this is very important when you want to do such kind of algorithm or such kind of project implementation. You should know that what exactly the frequency you have to run your algorithms or run your process pipelines. Otherwise it will be waste of energy in terms of networking or resource computation, everything. And you just imagine that you have your images and then you are putting into the pipeline, the process. This process it can identify and give you a result of anything. For example, it can give a title, it can give a description of the image. For example, it can description of the image. Okay, and then it can do objects, like what are all the objects which is inside the image, and localization where the objects are displayed in the image. I will show a simple example for each and every case so that you can understand better. So now with the AI vision, we have so much advanced so that we can do our OCR. OCR, right? Like, like even nowadays it can be handwritten images. Earlier it can detect only the images which are printed. Now it can do the handwritten images. Okay, it can detect the crop hints, for example, in the image where a particular person is there, or you want to cut it into 1:1 ratio, whether it has to cut it in the corner or center can be identified. Object recognition, it's something like in the image, what are all the objects are there. Facial, obviously now it can be identified where is the face and who is he, can be identified, or who is he or she. Detect landmarks, like when you send up in picture, it can tell you in the world where it is exactly. And motion analysis, it's basically will be used for the server rooms and some critical rooms. Somebody comes in, even you can see that this kind of motion analysis can be done in the corridor where the lights will be switched off. When someone comes in, it will be automatically on. Okay, kind of. So now I'll show you a small demo here with this. In the Google, you can create your free account and then free storage where you can put your images for analysis. Okay, and then let's see this one. See, this is all free. Whatever that I am displaying to you, it can be used for free. And then research purpose, yes, you can do it, or your academic purpose, you can use it. Sometimes it may ask a credit card because of to try to avoid the over usages. You can give it and ensure that you are not unnecessarily utilizing many things. Like we have been using since a long time, we never get charged. Okay, for simple things. And take an example of the classic example of OCR. See, you provide an image, it is able to identify what is there in the image, and then it can able to provide a boundary also there in the image, exactly. And here in this platform, either in the Google or AWS, Amazon, the good thing about, you can get the code directly there. You want a REST endpoint, you can have a REST endpoint. You have a Go language, Java, Python, anything you have, you can find it here. That is the one good thing. Okay, so now let us go and try it our own here in the DAO. Okay, let me to try. I already uploaded one image here. Okay, so I'll show the image. What is the image? AJC2. See, this is the image. This is a very simple image. You see, when I zoom, you can see it is blurring, right? These images is a blurry. It's not that much clean also. Okay, the actual size of the image is very small. I just purposefully took this image, okay, in order to do a demo. Okay, so now let me to go and pick up the Google link, and then I am putting the link here, and then let me to try it. So I am authenticating to execute under my account this API. Now Google can execute this and then come back. See what it found: St. Joseph's College, Trichurapalli, Pro Bono, Etwero. You see it was a very small image. So Google, from the image, it was able to identify the text very cleanly without any error. It is automatically interpreting, and then it is like picking the vertices where it is found in the image. Each and every text in the image where it is found, the boundary can be easily identified, and then it is marking it down where it is there. So this is how all those things will work. We no need to go nowadays. You no need to go and write many things. It is already there. Only thing is you should know that where it is there. Okay, this is all about OCR, like the character recognition and the crop hint. See what is crop hint, which is useful here. You just imagine there is a boy, there is a square image, but if I ask them to cut it 2:1 ratio, it means top, like 2:1, whether it has to cut in the first half or in the second half, where. Okay, but in fact it is better to cut it in the middle, right here somewhere, so that the subject is in the middle. This is what crop hint. So when I ask the machine learning to cut it, it properly cut it the subject area, because this area also not required, the top area also not required. That is important, because when you want to process a large amount of image, where you don't want a lot of things unnecessarily, you are saying that, okay, take an example of, you have a lot of unsized images, you want to cut it everything in one simple size. Then now when you cut, you should know exactly where you should cut, where is your subject is focused. That is useful for the crop hint. The same way detect faces also will be very much useful. Like properly it will identify. I'll show you that. For example, let us run this. It will properly identify the faces, and then it give you, for example, when you identify faces, what it does, it marks each and every features in our face. For example, your eye, your nose, your mouth, and where your ears, everything will be marked. For example, here you can say this, what is your boundary, and I'll show you that. See, right eye, what is the X, Y, Z, and right eye, left eye, eyebrow, each and every features in the face will be identified. These numbers will be saved into the database. Later, when you want to match it, you can do a close match and then get things done. Okay, I'll show you that what is the picture they were analyzing it. I think it's supposed to be a Google Cloud image. Hope somewhere I marked that cloud. I think. So this is the image. Yeah, this is the image. So it is marking whatever there in the image into the features. This is very important. Yeah, I'll try to talk a bit slowly. Are you able to, is it okay to follow it now? Okay. This is how each and everything. Now face detection, and detect image properties. Here, like for example, in this image, what are all the properties available, the colors, okay, dominant color, the gray, and then brown, everything can be detectable. So this is the another aspect of machine learning, where you provide the image, it gives you some of the properties about the images. The same way labels. Here it can tell you that, okay, this is the street image, and then there is a town, it looks like a town, and then it is a night scene, and there is a alley. Like, you provide the image, it gives you properties of the image, na? This is very important. So you can see that there is a number of things here. You gave one image. In the image, it can identify the text, it can identify the properties, you can identify the labels for the image, it can describe the image. Like, each and every aspect of the image can be extracted from this. Top of that, you can have your you can have your own logics into that, because each and every of this is called web services. You can call on a web service, or you can say API, and then get the result done. Before that, like, I'll give you the one more URL where you can try your own image. This is again from Google. You can put any image here. For example, let me take this image. I put the image here, and then I am saying I'm not a robot. Yes, someone, if you want to say something, yes, you can. I can see that there is a hands are rising. Hello. Okay, fine. If anything, like, you can tell me, or you can chat me, so that I can reply back there itself. Okay. So now you can see, it's like I already showed you, different APIs, whatever available in the Google. Here you see that I just put an image, then you can see it is able to identify the face, and then tell that what is, the probability of the image. Like, he's a soy or zero, sorrow, anger, objects like cap, dress, camera, shoes can be identified very cleanly, and then label, like what are the different object label which is available in this, and the image property. Like, you can get everything in about an image. Now I'll show you that I already told you, all those things is API based, so it is not bound to one language. It can be identified, it can be written any language to extract the property. So I already written a code to extract the properties of an image. Basically, this image man one. Here you can see that I already said I want to extract the property of the man one, which is nothing but I am calling a Google APIs. Here you can see that. Yes, Manisha, you can tell me. Okay, yes, if you want anything better, you can put it in the chat, so that I can look into, and then I can answer it back. Okay, so here you can see that it is completely Google code, where we are extracting different features out of it, and then we are displaying it. This is quite simple. Okay, you find this entire code there in the online itself. So now I am going to run it. So now it is analyzing the code, and then see the similar way, whatever that we have done there, it got the X, Y axis. After, when I get the X and Y axis, what I am doing is I am cropping the image. Like, I am going through each and every boundary. And then here you can see that I am cropping the image. And then we are saving it in a place. Okay, we are saving it into the path. Okay. So I'll show you that, like, where it is saved. Like, crop and analyze, you go here. The cropped one will be saved in this path. So let's go here. Console bean debug net cropped. See, it is cropped and showed. For you, let me delete once again. I'll show you once again. it is running. See, it cropped, and then it is immediately able to come back with this result. This is the advantage. Like, I didn't tell anything the machine. I gave the image. I told that I am interested in these properties, like shoe, outerwear, pants, jeans, and hat, something like that. Then with the algorithm, with the help of machine learning, we are able to extract the information. What we are extracting, we are saying that what is the property and where it is, like it's called localization, where it is in the image. Then using our algorithm, we are able to make it. I want to tell you one more thing here. When it goes this one, they recently added, when you click the code, you can see the start coding with generative AI. Okay, so let me go to the last one, generate with AI. You click here. Right. 1 minute. Disconnected. You click there. See now, let's put that I didn't say, I say that salary prediction using linear regression. I just enter. Then what it does, it automatically understands this context, and then it went and create the entire program for me. On top of that, you need to understand that the CSV, the columns, which all has been done the same way as what I have provided here. Na? It could pick up any column, right? It could pick up any column, but instead it did the same way. This is the advantage. Like here, you can see there is another small model change. It gave me 4 different options for the same. This is in like Microsoft, it is called Copilot. These guys are implementing here generative AI, something like that. Okay, the terms can be changed here and there, everywhere. The only thing is you should know that what to ask. Then the machine can develop a program for you. Then you understand the program and change accordingly for your needs. Nowadays, even for me, like I can say the last couple of months, even more than that, maybe I can say within 6 months, probably, we started to write more often with ChatGPT, where we go there, we know logics, and we know what is our specification, we know the logics, and instead of writing each and every line of code, we go and ask ChatGPT, I want this, and then the ChatGPT will provide me. Okay, for example, let me to go and say that the ChatGPT C# is my program language. C#. I want to pick. I want to extract the last word from a sentence. That's it. It is automatically will write the program for me. I didn't do anything, right? So it automatically goes, and from the word, it splits by space. So I got the word. Then it goes the last word, and then pick and then display. I'll say that I have an array of, I have a multi-line, last words of each line. So now, see, it gives me a sample. It's first split all the words, all the lines, and then it picks each and every line, it trims it up, and then it split, and like, each and everything can be done. Now I'm saying, it's a good program. Can you make it as a function? See, you got it right. Now what I'll do, I'll just go through this. Okay, I feel this all okay. Then I can take this and put it in my program. Nowadays, most of the time we are writing something like this. This works a lot. See, just imagine, in order to type this, Ideally, for me, it will take 5 to 10 minutes. It's not about type. You need to think and do it right now. So, okay, you think, you declare the variable, you write, and then do. Instead, nothing. You just go and tell what you need. It will give you, and then you copy and paste. 90% it will work. Only very few minor correction you're supposed to do. That's the one thing. But what you need to know is what to ask, because in your specification they never mention that you need to split this array into this blah blah blah. The specification will be completely different. Now for your entire specification, this is one small task. So you split up all your task in a small chunk. You can ask ChatGPT to do code for you. For example, the same I can say, can you make it in Python? That's it. See what I said, can you make it in Python? It doesn't make any sense actually. But because of the context which is available previously with this chat, it understand that I am saying make it Python this function, right? So it is automatically creating a Python function for this and then creating a main function for that. This is for context aware, completions. Basically, this is the completion. Okay. You can use a large using this chat gpt leverages, like you want to create a paragraph, you can say that for example here I'll say that okay, I have a project for revision using camera. Simple. So then it is automatically creating everything for me and then provides me back. Okay. The one thing which I need to ensure here is, like, it is has a knowledge of collective ideas. Now how it is related to mine, there should be it is a fabricator, right? So now I can take it, like I no need to go and write each and every line here, but I can analyze this. Okay, I can edit. Okay, this is not my idea. My idea has to be tweaked. Like you can give a here and there your touch, and then finally things will be ready. It will be very cool and easy. Even I can say that make it simple. For example, explain grade kids, something like this. Very simple. See, black hole as a concept itself, it's so huge, right? You can tell them to make them to very limit or very little. It will try to make sure that it is adapting what you are asking. For a PhD student, it's different, fourth grade, or I can say that make it in 2 lines. Just imagine, I'm talking about black hole in 2 lines. See, it is saying the black hole is a superpower, space, vacuum, sucks everything, even light, because of the gravity. Very simple, na? And it can able to give me a big, as well as it can able to give me a small. The only thing is what you're asking, how you're asking. That is important. That is what called prompt engineering. I'll come back to the prompt engineering in a bit later. Okay. So now you understand, right? The computer vision, we have face API, we have video face API. It's another one where you keep on send your images and it keep on indexing different faces. You try to match it, and later it'll tell you who is who. Like nowadays you can see any Samsung mobile or any Apple mobile. When you keep on take pictures, you can go to the gallery. You can see that is faces. It is automatically indexing different people. This is all based on the algorithm only. Okay. And I'll show you that one more, how real world now these guys are utilizing this AI. For example, here you can see how the AI used in real time. This is all AI avatars. See here, you can see that they are interacting with the human, and whenever when they are asking, they can immediately respond it back also. The same nowadays, even in India, a lot of news readings, is started, news channels, they started to use these AI models so that they can deploy it and they provide the text, it is automatically reading it. Okay, but this one is more advanced than that. This is interactive. When there is an audience, when they talk, they will talk, and in reality there is nothing like that, but in the live it can be automatically render and then they are sending it. Okay, now the other one is when it comes to generative AI world, you need to understand that because from the beginning we are keep on talking about AI model, AI model, AI model. Okay, you need to understand then where you can get the model. There are a lot of open source models are available either in the GitHub community or the main community is Hugging Face. I'll show you that Hugging Face community. This is the community where you can see that lot of models available. You can see that Microsoft model, Llama model, like there is a lot of models. For example, Stable Diffusion is one of the model which is very much useful for text to image generation. You provide the text. Now earlier what we see in the ChatGPT, you provide text and the response back as a text. You are asking different thing, it is able to create content for you and then provide. It is basically a text content, right? The same way you can have image content.